We will talk about the hardness of the water. Hardness of the water means hardness are of two types. First is temporary hardness, second is permanent hardness. Temporary hardness is due to the presence of bicarbonates of the calcium and magnesium in the water. And how can we remove? First, you boil the given water and add the lime. So by two ways we can remove the temporary hardness of the water. Second is permanent hardness is due to the presence of chlorides and sulfates of the calcium and magnesium. How can you remove this hardness? By washing powder, by ion exchange method. In ion exchange method we are using Na2, Al2, Si2O8, XH2O. We are saying this is zeolite, Z for zeolite. But one Na2 is attached with this zeolite. So Kalgan process, one of the compound is there which we are using to remove the permanent hardness, that is called Kalgan. Now next one is problem based on the hardness of the water. So hardness is expressed as either ppm or you can say milligram per liter of the calcium carbonate equivalent. Hardness as calcium carbonate equivalent is equal to molecular weight of the calcium carbonate upon equivalent weight of the salt into the given weight of the salt. So here I am writing molecular weight of calcium carbonate is 100, here equivalent weight of the salt, here milligram per liter of the salt, we can write. And one important point is this, always convert into CaCO3 equivalent. Whatever the salt is given, we will convert into the CaCO3 equivalent. So what type of question they ask? First type of question is calculate hardness of the water containing 162 milligram per liter of the calcium bicarbonate, like this. So how can we calculate? So first of all we will write here molecular weight of the calcium bicarbonate. So write molecular weight of CaHCO3 whole twice is equal to what? It is equal to 162 gram. And valency we know, valency here, valency of calcium you can take, this is 2. And what is equivalent weight of this compound? So it is 162 by 2 is equal to what? 81. So we got the equivalent weight. Now hardness we have to find. So hardness is equal to water by above formula 100 upon 81 into how much it is given? It is given 162, this much is equal to 200 milligram per liter. You can say like this, or simply you can say ppm, part per million, like that we can find it. Now we are going for the next question. What type of question they may ask? So the question is here, water contains 111 milligram per liter CaCl2, 120 milligram per liter MgSO4. Find total hardness of water. So what we will do? We will find the molecular mass of the CaCl2. So right here, molecular weight of what? CaCl2 is equal to how much? 111 gram. Valency is 2. Valency is equal to 2. And then equivalent weight. Here we will find the equivalent weight. That equivalent weight is equal to 111 by 2 means what? 55.5, that much. So by above formula what is the hardness? Hardness will be equal to what? 100 upon what is equivalent weight? 55.5 into what mass is given? 111 milligram. This is 111 milligram. Here we will solve this one. Then we are getting here 200. 200 we are getting. Now second part. Here magnesium sulfate is also given. So what is molecular weight of the magnesium sulfate? Molecular weight of MgSO4 is equal to 120. Similarly, valency same. Valency is equal to 2. Equivalent weight 120 by 2 means what? 60. Now find hardness due to the MgSO4. So hardness is equal to how much? 100 upon what was equivalent at 60 into 120 is equal to 200. So now total hardness. So here 200 and initial 200. So total 400 ppm we can write. Now we will try second question. Third question, sorry. So what is the third question? We will write here. See, calculate the weight of calcium oxide required to remove the hardness of the 10 to the power 6 liter of the water containing 1.62 gram of the calcium bicarbonate per liter. We know this is bicarbonate and this is temporary hardness. We are adding calcium oxide, then it will form CaCO3 which will be settled down and H2O we will get. So right here equivalent of calcium bicarbonate present in the hard water we will find. So right here equivalent of CaHCO3 whole twice present in what? Hard water in 1 liter. You can write, I am writing here 1 liter. 1 liter is equal to how much? It was 162 upon 162 by 2, like this. We will get here. This was 1.62. This was 1.62 and it was 162 by 2. How many equivalent we are getting? 0.02 we are getting. Now next, equivalent of calcium oxide, how much it is required? So we will write here equivalent of CaO required to remove what? Calcium bicarbonate CaHCO3 whole twice in 10 to the power of 6 liter. This is given in the question, is equal to how much? This equivalent is same 0.02 in 1 liter. So in 10 to the power of 6 we have to find. So that much. Now weight of calcium oxide, how can we find? So find the weight of calcium oxide. How can we find? This is the number of equivalent. We are getting 0.02 into 10 to the power of 6. Now multiply by equivalent weight. So molecular mass here 56 divide by 2. So we are getting here 5.6 into 10 to the power of 5 gram calcium oxide will be required. So like this we can do the